Hey guys, this is Holland Chambers Biology bringing to you a quick reminder on how to graph. For some crazy reason, at the end of school, a lot of you guys are completely forgetting the basic essentials for proper graphing. A lot of you guys are giving me almost like elementary kindergarten style. I'm just going to create a circle and color and that's it. Guys, a lot of you are going to be heading into honors chemistry or AP bio. And I really need for you guys to get back on track, especially with the ecology unit that you're heading into. Has a lot of graphing. So let's go through the proper way to graph, all right? First of all, please make sure to include the labeling over here on your X and Y axis, okay? Again, many of you guys are forgetting that your Y axis is the one that goes up and down. That is your dependent variable. So that's your data. Those are your numbers. So what numbers are you guys collecting? How many of something, or maybe it's a height, whatever it is, percentage, it's got to be a number, okay? Your x-axis is on the bottom here. That's what it is that you're studying, okay? So I'm studying, a dollar price range, or I'm studying a $2 price range, and how much do I get for that? If I'm studying a $3 price range, how much do I get for that? And then please make sure to not only include what it is you're studying, but, tell me what it is. So over here on the graph, you can see that it's $1, $2, $3, and this is the price per bushel. This is not the title, okay? So this is just the price per bushel. Here is my quantity of, how much is, it looks like it's demanded per week. And so you have your graph title that's going to be on the top, which is the price of corn per quantity demanded. And so that way I know as a reader what it is that I'm looking at, and then specific data, okay? Now, if you guys are doing a bar graph, so here's our example of a bar graph, trees in a park. So this is your observation of nature lab. I've got, 6 pecan trees. It looks like I've got, almost 20 sycamore trees. So I know that these are all various trees in a park. There's specific data, so simple bar graph. And then of course, here's my number of trees, 0 to 25. These are my specific types of trees that I'm listing. And of course, you need to identify your independent variable, which is the type of tree, okay? Now, a line graph, on the other hand, is a little bit different. So a line graph, this way, up over here, is going to be tracking data over time. So I'm not just going outside and counting how many trees I see. I'm not going outside and just, seeing how many butterflies I see, or analyzing a specific bushel of corn. What I'm doing is that I'm actually going to the beach every day for a month, and I'm going to take note of the type of plankton that is in the water. So I'm going to start documenting. On day 1, I had 4 different types of plankton. On day 10, I had 20 different types of plankton. And so because you're tracking it over time, day 1 to day 30, or maybe minute 1 to minute 60, okay, it's over time. That's when you're going to create a line graph. Now, line graphs are the same thing as bar graphs because you're setting it up exactly the same, but now we're going to connect the data together to correlate a trend, okay? So again, dependent is my numbers over here. So these are my students in thousands. This is my school year on the bottom, so that's what I'm looking at specifically, is this, the average daily attendance over the years of these students. And so back in the 1970s all the way to 2000, again, I've labeled the independent variable school year, and I've included up here on the top your title. Now, because there are 2 lines here, you do need to distinguish which data is what, and so therefore you're going to need to include a key. Now, up here on our bar graph, I'm just looking at trees, so just keep it one color. You can also do, rainbow color, the pecan's red, elm's blue, sycamore's green. That's totally fine too, okay? You can totally include a key over here, but this is pretty to the point that you don't necessarily need a key for that. If you were to do a double bar graph, okay, so add a second set of data, then you would need a key because that second bar there needs to be in a different color. Okay, so one more time, bar graph is just specific data at a moment in time, create your bars. Line graph is going to be over time. So I'm analyzing data over time, whether it's one set of data or two or three. I'm going to color code those lines. I'm going to connect the dots together and make sure to label everything. Now, some of you guys try to get super fancy and you start to create a scatter plot. Now, again, please do not do this if you don't understand what it means. So some of you guys just list a bunch of dots on your graph and then you don't do anything with it. Well, technically that's wrong, okay? So let's go ahead and look at this one real quick. Here's my title, golf ball distance versus club head speed. Now, scatter plot graphs are actually correlating two sets of dependent data. So that's data, data. There is no independent, okay? It's just data, data. And so that's when you go to correlate specific trends, okay? So if I got a specific distance over speed, does my speed increase over distance or does it decrease over distance? Again, here are my numbers. There are numbers here, so two dependent. And please, again, label your independent, dependent factors. So what am I looking at? So miles per hour and then yards, all right? Now this is another classic one that you'll see. Sorry, my husband's mowing the lawn. My grumpiness over hours of sleep. So if I only have, say, and again, this isn't mine, but it looks like mine though. If I only have 4 hours of sleep, I'm really grumpy, okay? And then as my hours, dependent, okay? As I sleep more, 8 to 10 hours, my grumpiness goes down, okay? And so you always, in a scatter plot, which a lot of you guys forget, you must include the best fit line, okay? If you don't include a best fit line, then I don't know what's going on with your data. It's just a bunch of dots everywhere. So you need to figure out, okay, is there a trend in my data? And in this particular scatter plot, yes, there is. The more sleep I have, the less grumpy I am, okay? Now the last one is the one that you guys are focusing in on with a lot of your labs, like the plastic pollution lab that you're gonna be doing. Now the M&M lab, that was the genetic drift, many of you guys did your pie graphs all wrong, okay? So instead of taking away a whole bunch of points, I just did a -1 or -2, but I wanna say almost 100% of you guys did this wrong, okay? Pie graph, pizza pie, 100%. Most of you guys know how to slice the pie perfectly into your 25s or 15% or 30%. That's great. Many of you guys also were just simply coloring the graph just like this, but then you completely forgot to label the graph. Now this one is just a real brief intro. What I want to point out here is that you have to have a title with a pie graph. You also need to have a key. Now, notice this labeling. Guys, they're not labeling it inside the pie graph and they're not altering the label so you have to look upside down or to the side to, figure out what's inside the pie. Everything is horizontal, okay? So we've got our chains, our brakes, our saddles, our road frames. Notice that there's a branch, it's horizontal, and then it spikes up to show you that that piece of the pie is for the road frames. This piece of the pie is for the pedals, okay? Now what they're missing in this specific graph is, anyone? The percentage, okay? So you would say pedals, 1%, okay? Put in little parentheses. Road frames, put in parentheses, 25%, okay? And then your key over here would have all the different colors with all the different data that you're analyzing. This down here is a little bit more so what I'm looking for, but again, they're missing the brackets. So you guys need to include these horizontal brackets within your pie graph. So here's our title, favorite movie genres in Miss Smith's film class. Here is my pizza pie, which again, most of you guys are doing. Many of you guys are doing the key, but you're not actually labeling it as key. So make sure to write the word key. Here's all my different film classes. And then please make sure, especially because a pie graph tends to get really thin slices, do not write the percentages all inside or some inside and some outside. Okay, keep it consistent and keep it all on the outside. So that way, as a viewer, I'm viewing your data going, oh wow, most of the people, real quick, is 27% love comedy. Done. Okay, most of the people over here, the 8%, guess they don't really like foreign and they don't really like science fiction. Okay, so I can see the data very quickly and I can see the percentages. All right, so please keep that in mind when you are creating graphs. So pie graphs, scatter plot graphs, whether it's a line graph or a bar graph, the proper way to label and show your data in a scientific way. All right, let me know if you have any questions. Otherwise, this is Solon Chambers checking out.